Hello, I'm Tommy and this video is sponsored by manscaped.com, and in this video I'm going to play their new lawnmower 3.0 body trimmer designed for grooming men's body hair below the waist. And the sound comes from a powerful 7000 RPM motor, great for grooming, and you can easily charge this device with this great USB powered charging dock. And if you decide to buy the perfect package, you're also gonna get some great stuff. This bag here, and this ball deodorant, and this ball toner, and even these boxer briefs. You'll get 20% off plus free shipping with my promo code device20 at manscaped.com. Let's begin. Like I said, the sound comes from the motor. And if we want to turn this device into an instrument, we need to control the motor. We're gonna connect some wires to the motor to be able to control it. We need to remove this case around the motor and the electronics inside. Let's remove these screws and see what happens. If I press here, whoa! Now I've removed all the screws that I saw, and now I can open this. Oh, whoa! Okay, so this is how it looks like inside the casing. Here's the motor, here's the chip. So here's the battery. We're gonna measure the voltage. So the battery is about 4 volts. We can use a power source of a little bit higher voltage than this battery here to get higher sounds from the motor. Here's the battery, we're gonna recycle that. And my own wires will be these two conductors that form this cable. So let's put this in. And through that hole also, and I'm gonna connect these wires to these wires that go into the motor. And I'm gonna use this heat shrink tubing to isolate the wires from each other. And this is now my plus wire. I'm going to connect it with this guy here. Let's solder those wires together. Let's cover these terrible joints with this heat shrink tubing. And then let's close the casing. And you are here. And boom, it looks like the original product. So now the device is connected to the power source. If we raise the voltage, the pitch goes higher, the motor spins faster. And if we lower the voltage, we also lower the speed of the motor and we get a lower pitch. We need to somehow automate the change of the voltage to be able to play some songs. To automate the voltage change, we're gonna need a thing called PWM, which stands for pulse width modulation. We're not actually changing the voltage with PWM, but we're switching the power on and off at a very rapid pace in intervals of like a few milliseconds, and for that we're gonna need a bunch of things. Here I have a component called H-bridge. The H-bridge acts as kind of a gate between the power source and the motor, and the gate is controlled by this Arduino microcontroller, and this Arduino here sends signals to the H-bridge, and that's how this small computer can control if the gate inside the H-bridge is open or closed. Before we can play any music with this device, we need to tune it. We need to find the PWM values which correspond to each note. A higher PWM value leads to higher motor speed, a higher pitch, a higher note, and a lower PWM value leads to a lower note. I'm gonna use this guitar tuning app and this computer. I've connected this microcontroller to this computer here. I'm gonna play a song called The Saints Go Marching In, and for that song we're gonna need 5 notes, and I'm gonna play the song in G major key. So let's first find the PWM values for the note G. Let's first try a PWM value of 1500. Okay, we need a G, so that was a bit sharp. Let's try 1400. Okay, we're getting closer. Okay, now I'm almost happy with this note, but if you listen carefully, it goes like We want to go it like straight at the correct frequency. So to minimize the slide in the beginning, we're gonna use more power in the beginning of the note to make the motor reach the target speed more quickly. And now it sounds like this. Okay, we're almost there. Just one more tiny adjustment. We don't want that slide at the end of the note. So at the end of each note we want to switch the direction of the current, and we want to kind of try to spin the motor backwards so that it stops more quickly. Okay, now I'm quite happy with my G. Next I just need to find the correct PWM values for all the 4 notes that there's left. Okay, now I've found the PWM values for each note, and next, in order to play the song, we'll need some code. Now, I'm not gonna cover all the details of the code in this video, but on my computer I've made a program that I use for all my videos actually. That program can translate a sheet music file into a form that a microcontroller will understand. And I told that program on my computer the PWM values that correspond to each note. And now I've uploaded the file from my computer into my microcontroller, and now if I press here, we should hear the Saints. Okay, that was okay, the song was recognizable, but as you could hear, some of the notes were out of tune, and that's because the motor heats up during the song, and a better result would need some more tuning. So that's all for this video, but if you have some ideas what you'd like me to show you next, let me know in the comments below. Bye bye! But we're turning the power on and off at a very rapid space. Rabbit space.